Bismillahirrahmanirrahim. This is our 11th lecture and which is about introduction to machine learning. So we have very important and a very interesting topic today. What is machine learning? इंसान की आदत है कि वो इंस्ट्रक्शन से सीखता है और फिर सीख के एक्सपीरियंस हासिल करता है और ज़िंदगी में कुछ परफॉर्म करता है। इसी तरह अगर इंस्ट्रक्शंस मशीन को दिए जाएं और इंसान मशीन को सिखा दे तो मशीन भी फैसले ले सकती है। मशीन से भी बहुत सारे काम ऑटोमेटिकली परफॉर्म किए जा सकते हैं। सो अकॉर्डिंग टू द डेफिनेशन, इसको बहुत आसान करके हम समझाएंगे और एग्जाम्पल्स भी देंगे। अकॉर्डिंग टू द डेफिनेशन, इट प्रोवाइड्स द मशीन द एबिलिटी टू लर्न ऑटोमेटिकली एंड इम्प्रूव द एक्सपीरियंस विदाउट द नीड ऑफ बीइंग एक्सप्लिसिटली प्रोग्राम। अच्छा भाई, मशीन को प्रोग्राम ना किया जाए एक्सप्लिसिटली और मशीन डेटा से, यूज़फुल इंसाइट्स ऑफ डेटा से, डेटा के पैटर्न से कुछ सीखना शुरू कर दे। इसकी एग्जांपल लेते हैं, फिर उसके बाद इस पे मज़ीद बात करते हैं। नेटफ्लिक्स सब लोग मूवीज़ देखने के लिए इस्तेमाल कर रहे हैं। उसका रिकमेंडेशन इंजन वो किस तरह आपको बता रहा है कि यू आर इंटरेस्टेड इन सच टाइप ऑफ मूवीज़। फेसबुक टैगिंग, जीमेल स्पैम फिल्टरिंग, स्पैम ईमेल कैसे आपके इनबॉक्स से निकलकर स्पैम में डायरेक्टली जा रही हैं। मशीन लर्निंग को समझने के लिए या मशीन लर्निंग पर बात करने से पहले कुछ टर्म्स और डेफिनेशंस जिनका जानना हमारे लिए ज़रूरी है। एल्गोरिथम, अ सेट ऑफ रूल्स एंड स्टैटिस्टिकल टेक्निक्स यूज्ड टू लर्न पैटर्न्स फ्रॉम द डेटा। ऐसे सेट ऑफ रूल्स या ऐसी टेक्निक्स जिनसे हम क्या कर सकते हैं, लर्न पैटर्न्स फ्रॉम द डेटा। ये बड़ी इंपॉर्टेंट बात है। एंड अ मॉडल, व्हाट इज अ मॉडल? अ मॉडल इज ट्रेन्ड बाय एल्गोरिथम एंड यू हैव ऑलरेडी स्टडीड व्हाट इज एन एल्गोरिथम। A set of rules and statistical techniques used to learn patterns. What is the predictor variable? It is the feature of data used to predict the output. You have make a model that will tell you, that will classify that the patient is affected or not, that the patient is affected with virus or not. So you have done something in the model, and how the model is prepared. The model is always prepared by using a machine learning algorithm. And what is the predictor variable? The feature of data which will use to predict the output. And what is the response variable? The variable that needs to be predicted. Training data और testing data की एग्जाम्पल कुछ इस तरह लें। यू आर मेकिंग, हमने बनाया, बल्कि मैंने बनाया अपनी टीम के साथ मिलकर, स्किन डॉक्टर एप्लीकेशन, एक ऐसी डिवाइस जो कि स्किन की तस्वीरें लेती थी और हमें ये बताती थी कि इस पेशेंट को स्किन की डिजीज़ है या नहीं। सो वी हैव मेड अ मशीन लर्निंग मॉडल। हाउ द मशीन लर्निंग मॉडल इज़ मेड? हमने उसको डेटा प्रोवाइड किया। वी प्रोवाइड द ट्रेनिंग डेटा एंड ऑलवेज रिमेंबर व्हाट इज द ट्रेनिंग डेटा? दैट सेट ऑफ इमेजेस जिसके अंदर बहुत सारी तस्वीरें हमने कंप्यूटर को प्रोवाइड की उसको सिखाने के लिए कि भाई ये जो इमेजेस हैं ये बीमारी वाली इमेजेस हैं और ये जो इमेजेस हैं वो बगैर बीमारी वाली इमेजेस हैं। द पर्सन इज अफेक्टेड और नॉट। सो वेन एवर यू आर ट्रेनिंग a machine, always remember that you have to provide the training data, and training data is always 80% and the testing data is 20%. So why machine learning is important? Because I already told you that every person of on earth is generating 1.7 MB of data. So we have to use machine learning. There is lots of data generation in order to move the decision making, in order to predict the forecast, the sales, the downfall in stock market, the anomalies in our IoT devices, to uncover the useful insights from the data. That's why machine learning is very important. So let us know the process of machine learning. Before explaining the example, I want to discuss the process. First, we have to define the objective. Why we are performing machine learning? We want to predict the disease of our skin. We want to predict the forecast of sales. We want to predict the anomalies in a machine. That is our objective. The second part is the data gathering. The second is preparing the data. The third is explore that data. What the patterns of the machine is saying. The second is building a model, and we already discussed what is a model. A set of statistical rules to learn patterns from the data, and after the testing and training data, we will evaluate the model, and at last we will make predictions. So the machine learning process involves a predictive model. और वो प्रिडिक्टिव मॉडल किस लिए इस्तेमाल होता है? जो किसी भी प्रॉब्लम का सलूशन फाइंड करने में हमारी मदद करे. सो हम एक एग्जाम्पल लेते हैं, बट बिफोर गोइंग टूवर्ड्स दिस एग्जाम्पल आई वॉन्ट टू एक्सप्लेन मशीन लर्निंग in a crystal clear concept. So let us move towards the YouTube video, and then we can discuss more about weather forecasting. I want to make this lecture more interesting. So let me move towards the real life example. So please focus on the example, and then we will discuss. So start getting the concept from this video. This is very interesting.
Now have great computational powers. So there are
Let us start.
So that's Paul. He loves listening to new songs. He either likes them or dislikes them. Paul decides this on the basis of the song's tempo, genre, intensity, and the gender of voice. For simplicity, let's just use tempo and intensity for now. So here, tempo is on the x-axis, ranging from relaxed to fast, whereas intensity is on the y-axis, ranging from light to soaring. We see that Paul likes the song with fast tempo and soaring intensity, while he dislikes the song with relaxed tempo and light intensity. So now we know Paul's choices. Let's say Paul listens to a new song. Let's name it as Song A. Song A has fast tempo and a soaring intensity, so it lies somewhere here. Looking at the data, can you guess whether Paul will like the song or not? Correct. So Paul likes this song. By looking at Paul's past choices, we were able to classify the unknown song very easily, right? Let's say now Paul listens to a new song. Let's label it as Song B. So Song B lies somewhere here with medium tempo and medium intensity. Neither relaxed nor fast, neither light nor soaring. Now can you guess whether Paul likes it or not? Not able to guess whether Paul will like it or dislike it? Are the choices unclear? Correct. We could easily classify Song A. But when the choice became complicated, as in the case of Song B, yes, and that's where machine learning comes in. Let's see how. In the same example, for Song B, if we draw a circle around the Song B, we see that there are 4 votes for like, whereas 1 vote for dislike. If we go for the majority votes, we can say that Paul will definitely like the song. That's all. This was a basic machine learning algorithm also. It's called k-nearest neighbors. So this is just a small example in one of the many machine learning algorithms.
I hope that you are clear with the examples given. Now I am just discussing a problem. If we want to forecast the weather using machine learning, so I am going to tell you the steps which we are going to use in the next sessions. So वो examples अगर आपको weather forecast करना है machine learning से, तो क्या क्या स्टेप्स होते हैं, तो सिर्फ इन स्टेप्स को पढ़ना है और इनका आइडिया लेना है. वी आर गोइंग टू डिफाइन द ऑब्जेक्टिव टू प्रेडिक्ट द पॉसिबिलिटी ऑफ द रेन. हम ये मालूम करना चाहते हैं कि भाई बारिश होगी या नहीं, पहला ऑब्जेक्टिव. तो हमें क्या क्या चाहिए, व्हाट वी आर ट्राइंग टू प्रेडिक्ट, व्हाट आर द टारगेट फीचर्स, इनपुट डेटा क्या होगा, प्रॉब्लम क्या आएगी. सेकंड स्टेप डेटा गैदरिंग एंड कलेक्शन, डेटा कैसे कलेक्ट करेंगे. थर्ड स्टेप प्रिपेयरिंग द डेटा. द फोर्थ स्टेप एक्सप्लोरेटरी डेटा एनालिसिस. और मैंने इसमें बताया है कि बिकम अ डिटेक्टिव एंड डीप dive into the data, understand and get the patterns and trends from the data, find the correlation between variables. और फिर जब आपको सब कुछ मिल गया है, you have to clean the data, you have to prepare the data, you have to perform exploratory analysis. Then step 5 is to form, is to make a machine learning model, and step 6 is to evaluate the model by using the testing data set. I already told you what is the training and testing data set. Let us now you will find the accuracy of the model, the precision, the recall and other things which we have already discussed in the confusion matrix. So और भी बहुत सारे तरीके हैं जैसे पैरामीटर ट्यूनिंग और क्रॉस वैलिडेशन, ये हम आगे सारी चीज़ें पढ़ेंगे. So in this video we are discussing the steps of weather forecasting or any machine learning problem, how you will divide it into steps, into 6 steps. The seventh and the final step is the predicted outcome, to find or to improve the accuracy of the model, and what to know about it, whether it is a classification problem or another type of continuous problem. So these are the 7 steps you can use for a sample problem like you are going to predict the weather forecast. So let me start the video, a detailed video about machine learning, and then we will close the topic. This video will help you to understand the concept and the types of machine learning more clearly. So let us start.
In this lesson, you'll get a high-level look at the field of machine learning and how it's evolved. We'll discuss a bit of the history about how machine learning has progressed. At the end of the lesson, we'll discuss some emerging technologies and how we think machine learning applications will change much of how the world works today, from health to transportation to communication. Current uses of machine learning come from the combination of two perspectives. One is the perspective of statisticians, and the second is that of computer scientists. The statistician's perspective has evolved from understanding data. The field of data analysis was originally a field of mathematics, based on questions like, how do we better understand the mechanisms that create data? From these questions, probability-based models were used to model the world around us. For example, there's a distribution to model expected scores on a test, number of daily incidents on a stretch of road, or how frequently words show up in a body of text. The derivation of distributions like these were breakthroughs for mechanisms that could create data in the real world. These mathematical functions were used to describe essentially all aspects of our daily lives. But as it turns out, these models are an oversimplification of the complexities that exist in the real world. And often the probability-based models that were created for a situation did not do a very good job of simulating the actual data observed in the world. In the next video, you will see a different perspective, that of a computer scientist. The combination of the computer scientist and statistician viewpoints results in the diverse techniques used in machine learning today. In the 1950s, computer scientists were coming to the realization that it might be best if they didn't hard-code every decision a computer would make as essentially never-ending if-else statements. Rather, computers should determine what was best by looking at data and recognizing patterns. This idea of recognizing patterns in data is what is commonly recognized as machine learning. Drawing from the world of statistics, In order to avoid hard-coding rules, these new techniques involved rules that were based on distributions. But using statistical distributions as generators of data exposed pretty large discrepancies between the data generated by our models and the data you actually obtained in the real world. Machine learning has continued to evolve into extremely flexible models based more and more on data, and less on human-enforced if-else statements. These flexible models have been shown to predict better than previous well-defined modeling techniques. This leads to the current state of machine learning, where prediction has become key, often creating extremely flexible and complex models. These complex models outperform models that follow if-else statements set up by humans, as well as those that follow distributions that are known as well-known probability distributions. Unfortunately, these complex models often leave the why of a prediction unknown. Though these techniques might be able to identify tumors better than doctors, or play at a world-class level in the game of Go, the individuals creating these models can't always explain why they're making these decisions. Machine learning has three main categories: supervised, unsupervised, and reinforcement learning. In supervised machine learning, our algorithms learn from labeled data. After studying the labeled data, these techniques are able to determine which label should be given to new data based on observing patterns and associating those patterns to new unlabeled data. Supervised learning can be divided into two categories: classification and regression. Classification models predict a category that an item belongs to. Many people believe that these models are used for events with only two possible outcomes, like whether an email is spam or not. But most can actually be extended to predict any number of categories. For example, there are classification techniques that allow us to predict which of many breeds a dog belongs to. Alternatively, regression models predict a numeric value, like home price or an individual's height. You will learn about these techniques in the supervised machine learning part of this program. Looking at the next category of machine learning, unsupervised learning creates models for data when there are no pre-existing labels to train on. So in a sense, it can be called unsupervised. It turns out that the applications for these techniques are pretty vast, from reducing a dataset to a fewer number of useful features, to grouping similar items, to building music recommendation systems. The final type of machine learning is known as reinforcement learning, which is used to train algorithms that learn based on taking certain actions and receiving rewards for those actions. The applications of reinforcement learning include self-driving cars and game-playing agents like the recent agent that beat experts at the game of Go. This map gives a nice overview of the prominent areas of machine learning in use today. If you've been following the headlines related to artificial intelligence and machine learning, you probably have heard of deep learning. Deep learning has beaten essentially all other machine learning algorithms in its ability to predict, and it can actually be used for supervised, unsupervised, and reinforcement learning. From a historical perspective, the growth of this technique makes a lot of sense. Over time, we've cared less and less about how we make predictions, and now we care more about the accuracy of our predictions. This connects well to the advancement of deep learning, where we rarely understand all of how or why our model makes certain predictions. Unfortunately, deep learning is not the solution to every problem. It has three major barriers to entry. First, you must have enough data. Deep learning requires a lot of data. Second, you must have the computing power. In order to reach superhuman performance in the game of Go, Google's DeepMind AlphaGo required 1,202 CPUs and 176 GPUs. Third, You probably won't understand why certain decisions were being made, given the complexity and flexibility of these algorithms. For these reasons, not every application of machine learning is one that requires deep learning. You'll be getting some practice using deep learning in this program. However, we have an entire deep learning nanodegree program available on this subject, so it's not the primary focus of this program. If you're interested in solving machine learning questions that fall into either supervised or unsupervised learning, the most popular open source library in the world for solving these problems is Scikitlearn. Scikitlearn provides any data scientist the ability to use the most advanced techniques in supervised and unsupervised machine learning easily and for a variety of situations. You can expect that Scikitlearn will continue to be used for machine learning in both industry and academia for the foreseeable future. In the following lessons, you will get comfortable solving a range of problems using this library. Machine learning models have the power to summarize data efficiently and intelligently. Unfortunately, since the data in our world often holds errors and biases, the models we build will hold these same errors and biases. As an example, imagine you want to build a model to predict who the best candidate is for a job based on existing data. If there were biases in the historical hiring patterns based on gender, race, age, economic status, etc., these biases are going to be held by any predictive model you build based on these data. Unfortunately, the bias held by humans will transfer to computers, so long as humans are the creators of the data. Images, text, speech, and video are all data being ingested by computers in today's world to make database decisions. But humans generate these data. The potential biases in the data created as a result of our human biases should always be on your mind when building your models. Real-world validation of your models is even more important than statistical validation. This lesson provided some more context as to the current state of machine learning and how it's evolved from the fields of statistics and computer science. You got to look at 3 branches of machine learning: supervised learning, unsupervised learning, and reinforcement learning. We also discussed at a high level Scikit-Learn as a library in Python for machine learning, and deep learning as a popular technique currently leading the way. You will get more experience with both of these in the material ahead. Finally, we looked at the ethical challenges ahead of us in the field.